Welcome to Lesson 4.4. More about factoring polynomials. This is part 3 of the series. So we're going to start by looking at x squared plus 620x plus 88,179. And we're going to go ahead and factor this. So remember what we're looking for. When we factor this, we're looking for the numbers that multiply together to give me 88,179 and add together to give me 620. Boy, that should be a short list. Can you sense my sarcasm? Folks, this is a hard problem. This is a really hard problem. But you know what? If you know one of your factors, it can be a ton easier. Like, for example, if I go back to this problem, and again, I'm looking for 88,179, the product, and the sum being 620. If I all of a sudden turn around and tell you, hey, one of those numbers is 399, then really quickly, you can just do some math. You can do 88,179 divided by 399, and you can come up with the other one, which is 221. And all of a sudden, that problem that was really difficult to factor becomes super easy by just doing a little bit of division. And that's kind of the theme of the lesson today. But I'm not going to be giving you numbers here. Instead, I'm going to be giving you a polynomial. So in this case, x to the third minus x squared minus 14x plus 24. And I'm going to give you this polynomial, and I'm going to tell you that x minus 2 is a factor. And all we got to do is do a little division. We just know if something is a factor, that means that it's going to go in evenly. So we're going to look at x to the third minus x squared minus 14x plus 24. And we're going to go ahead and we're going to divide that by x minus 2. Now, it doesn't really matter what method of factoring you use. What method of division you use. But folks, I'm going to use synthetic division because it's easy. I mean, there's not one of you that didn't tell me synthetic division was a lot easier to do than long division. So I'm going to go ahead and do synthetic division with this problem. Folks, just a reminder, this is x minus 2, so positive 2 is what you're going to use for synthetic division. Remember, bring down the first number. Then you're going to do some multiplication, some adding, some multiplication, some adding. And here's the kicker. Right here, this remainder had better be 0. If you do not get a remainder for 0, check to make sure you did your synthetic division correctly, either by picking this number the right way or by doing these values correct. Make sure, because if I'm telling you x minus 2 is a factor, you better get a remainder of 0. That means that it goes in evenly. Okay, so the answer to this question is, of course, yes, x minus 2 is a factor. Real quick for me, check to see if x plus 5 is a factor of x to the third minus x squared minus 14x plus 24. Okay, that same polynomial we did on the previous page, but see if x plus 5 is a factor. Go ahead, pause the video. I'm going to show you here the work momentarily. All right, so I took my -5, which is what I would do when I was doing the synthetic division. I'm going to go ahead and do the math here real quick. So let's see here. That's -6. That'll give me 30. -14 plus 30 is 16. 16 times is -80. Yeah, I got -56 here. So since the remainder is not equal to 0, x plus 5 is not a factor. Okay. So again, if I get the remainder of 0, what I'm looking at was a factor. If I don't get a remainder of 0, then it's not a factor. We're going to change the direction slightly. We're going to show that x plus 3 is a factor of the polynomial x to the fourth plus 3x to the third minus x minus 3. And then we're going to take it a step further. We're going to factor it completely. So in these problems, since I'm telling you that x plus 3 is a factor, I'm saying show that that's true. We're not going to start the problem out any different. We're still going to do that -3. We're still going to set up our synthetic division. Hey, folks, be real careful. Look there. I went from x to the third to x. Don't forget to fill in your gap. All right, so I got my synthetic division set up. I'm going to go ahead and go through with that synthetic division. Doing the math. I'm multiplying, I'm adding, I'm multiplying, I'm adding. Right? And I better get a remainder of 0 because I'm saying show that x plus 3 is a factor. Now that I have that, what this tells me is that if I took x plus 3, and if you remember what this means right here, that means x to the third minus 1. So what I did was I did the division. And I said that if I took x to the fourth plus 3x to the third minus x minus 3, that x plus 3 is a factor. And if I took x plus 3 times the result of what I got when I did my synthetic division, I know that that had better equal this x to the fourth plus 3x to the third minus x minus 3. It will. It has to. Because think about that. If I told you that 12 divided by 4, right? If I know that 4 goes into 12, the result is 3. A different way that I could write that problem is knowing that 12 is equal to 3, that result that I got there, times 4, the number I divided by. Okay, so that's no different than what I'm doing. I'm simply rewriting the problem as the product of two things. And now all I have to do is I have to keep factoring. So my result now, it says factor completely. So I take my answer here, my x plus 3 is factored already, and I make sure, can I factor that x to the third minus 1 more? And yes, I can. Based upon all the factoring we did in the last lesson, I know that I can factor that down further to get that as the fully factored form of this x to the fourth polynomial that I started with. All right, that's a lot. Let's do one more together. I'm going to show you that x minus 4 is a factor of x to the fourth minus 2x to the third plus x minus 2, and then we're going to factor completely. Okay, so here we go. First, we'll start off with that synthetic division. Okay, I'm going to make sure, got another blank I got to fill in with this problem. Okay, no problem. Okay, I'll do my synthetic division. All right, here we go. I'm still going. Okay, I get that remainder of 0, which again, I had better get. Okay, this result right here, that result tells me that I have x to the third plus 1. Okay, so I'm going to start here. I got that x to the fourth minus 2x to the third plus x minus 2. I can rewrite that using that x minus 2 from the original problem and knowing that I get x to the third plus 1 left over. And now it's all about factoring down what I have left. So this x to the third, I'm going to keep factoring. That's a perfect cube binomial, so I'm going to use that shortcut and factor it down further. All right, folks, why don't you try this one on your own? Show that x minus 6 is a factor of x to the third minus 5x squared minus 6x, and then factor completely. Okay, good luck. Pause the video now, try the problem. I'll show you the solution momentarily. So I'll go ahead and do my synthetic division. I'm going to use that 6. Let's see, I got 1, I got negative 5, I got negative 6, and I got 0. Okay, I'm going to bring down my first number. Go ahead, I'll do the synthetic division. 0, and then 0, and I get 0. So wow, okay, 2 zeros at the end. But that last one is my remainder. Don't forget that. We had to fill in the blank. So what does that mean for this problem? That means that x to the third minus 5x squared minus 6x, I know that that x minus 6 is a factor. X minus 6 is a factor. And what's left over? Well, let's see here. That would be my constant, so that's my x, and that's my x squared. So I get x squared plus x. I could write the plus 0, but it's not necessary. Now I just need to make sure that this junk that's right over here left over is factored completely, and it is not. There, in fact, is a GCF that I can pull out of x. So just to rewrite this just a little bit, I'm going to change the order because I don't like that constant. I like the x out front. And that would be the way my final answer could be written. I mean, either of those forms is correct, but the bottom one is a better form of the answer. All right, folks, that's all I got for you today. We'll practice more of these, of course, in class. Otherwise, good luck. If you have any questions, please let me know.